In algebra and in other fields in which algebra is used, we frequently encounter first-degree equations in two variables. For example, something like this, 3x plus 4y equals 12. Okay? There are two variables in this problem, x and y, and this equation is first degree. Okay? The power for x is 1, the power for y is 1. Okay, now, what do we mean by a solution to this equation? We know that if we have an equation in a single variable, for example, something like 5x equals 10, then a solution to this equation would be an x value for which this would be a true statement. Okay? X equals 2 is a solution for this equation, because 5 times 2 equals 10. When you substitute x equals 2, you get a true statement. X equals 3, however, is not a solution, because 5 times 3 is not equal to 10. Okay, now we're going to use the same idea over here. The only difference is that a solution will be a pair of numbers, one for x, y, which when we substitute into the equation, turn it into a true statement. For example, x equals 4 and x equals 4 and y equals 0 is a solution for this equation, because 3 times 4 plus 4 times 0 is equal to 12. Okay? Substituting in x equals 4 and y equals 0. 3 times 4 plus 4 times 0 is equal to 12. You get 12 plus 0, which is 12. Okay, so x equals 4, y equals 0 is a pair of numbers that is a solution to this equation. On the other hand, x equals 0, y equals 4 is not a solution, because when we substitute in x equals 0 and y equals 4, we get 3 times 0 plus 4 times 4, which is 0 plus 16, 16, which is not equal to 12. Okay, let's examine other possibilities. If we were to let x equal 0 and y equal 3, we would have another solution, because 3 times 0 plus 4 times 3 is equal to 12. So this is a solution. All right. We could also let x equals 1. In case you're trying to figure out where I'm getting these values, okay, what you basically have to do when you want to find, say, a pair of numbers that constitute a solution for the equation, so you pick one of the values. Let's say I pick x equals 1. I want to find the y value, okay, such that x equals 1 and y equals that number constitute a solution to this equation. So what I would do would be look at this equation, 3x plus 4y equals 12. And I know I would like x to be equal to 1. So let x equals 1 and try to figure out what y is. Okay? Let x equal 1 in here. And we get 3 times 1 plus 4 times y equals 12. 3 plus 4y equals 12. You see we have an equation in just one variable. If you substitute a value in for x, for example, x equals 1, then you have an equation in just y. Okay? You solve this the way you've always been solving equations in one variable. We'll subtract 3 from both sides, and we'll get 4y equals 9, and divide both sides by 4 to get y equals 9/4. So if x equals 1, y equals 9/4 constitutes a solution to this equation. And you can, of course, just check this. X equals 1, y equals 9/4. 3 times 1 plus 4 times 9/4. 3 times 1 plus 4 times 9/4. You get 3 plus 9 is, in fact, equal to 12. Here the 4's cancel. You get 3 plus 9 equals 12. So this really is a solution. Okay, now some of the time you can do it in your head. Okay, if you let x equals 4, you get 12 plus 4y equals 12. You subtract 12 from both sides. 4y equals 0. Y has to be 0. Okay, but if you can't, there's absolutely nothing wrong with substituting in a value for x and then trying to find the y value that goes with it to form a solution. Okay, let's get some more. If x equals minus 4 and y equals 6. Okay, I'm just picking some more values. If x equals minus 4 and y equals 6, we also have a solution because we get, let me substitute in up here for you. X equals minus 4, y equals 6. 3 times minus 4 plus 4 times 6. This gives you minus 12 plus 24. Minus 12 plus 24 is plus 12. So this is a solution. Okay, that's enough for right now. By the way, this is taking up a lot of space, this method of writing down solutions, x equals this, y equals this. A nice shorthand way to indicate these solutions would be to put the solutions, in other words, the x and the y values, into parentheses. Put the x value down first and the y value down second. It has to be done in this way. We'll adopt this convention. Okay, if you see parentheses and inside the parentheses a number, comma, another number, okay, this will mean that the first value is an x value and the second value here is a y value. So instead of writing x equals 4 and y equals 0 is a solution, I could say 4 comma 0 is a solution. Okay. The second one, however, would be written 0 comma 4. Remember, it's the x value that has to go down first. 0 comma 4 is not a solution. By the way, writing the two numbers like this, we call this an ordered pair of numbers. An ordered pair of numbers. Well, obviously, they're a pair of numbers. They're an x and y value. Okay, the important word here is ordered. Okay, we are assuming the first value is the x value and the second value is the y value. The order is important. 4 comma 0 and 0 comma 4, they are not the same solution. Here, this is x equals 4, y equals 0. This is x equals 0, y equals 4. Okay, so it's an ordered pair of numbers. The order is important. The x value has to be written down first, always. Okay, now over here we see that we have many solutions to this equation. There happen to be actually many, many more. Whereas I can take any x value, write it down, and figure out the y value that goes with it in much the same way I found the y value that went with x equals 1. Okay, I could let x equal 2 and solve for y. I could let x equals 3 and solve for y. I could let x equals minus 100 and solve for y. Okay, every time I do that, I would be getting a different solution to this equation. There happen to be infinitely many solutions to this equation, infinitely many pairs of numbers, okay, that satisfy this equation. Since we can't list them all, it would be helpful to have some way of picturing this. Okay, we can't list all the numbers, all the solutions to the equation. So we'd like to be able to at least draw a picture, okay, of the solutions. Okay, in the 17th century, a French mathematician and philosopher named Descartes developed a very clever way of forming such a picture. Okay? The idea is to represent each one of these solutions by a point. Okay? And then when we look at all the points, okay, that represent solutions to the equation, we look at all those points together, we will get a picture of this equation. Okay, a picture of all the solutions of this equation. Such a picture is called a graph. Okay, the picture of the equation that we're going to get is going to be called the graph of the equation. Okay, now, Descartes accomplished this by means of a system which we call the rectangular coordinate system or the Cartesian coordinate system, named after Descartes. Okay, what he did was to take a number line. Okay, we've seen number lines before. We take a number line, and we'll designate, say, this as the positive direction. We'll have, say, 0 here, +1, +2, +3, +4, and so on. And to the left of 0, of course, -1, -2, -3, -4. Okay, and then run another number line perpendicular to this number line, crossing through 0, okay, like so. This other number line, okay, also has a positive direction. We will, although this is arbitrary, we're going to adopt the convention that the number line that's horizontal here will have its positive direction on the right. Its negative numbers will be on the left, okay? The number line that is vertical will have its positive direction upward, and its negative numbers will be down here, okay? We will designate this also as 0 for the vertical number line. This will be +1, +2, +3, +4, and so on. And down here we will have -1, -2, -3, -4, and so on. The point where the two number lines intersect, which is 0 on both the number lines, okay, is called the origin, okay, of this coordinate system, the origin. Where the two number lines intersect. So we have here two mutually perpendicular number lines. Okay, they intersect here at right angles. They're perpendicular to each other. The place where they intersect is known as the origin. It's the 0 on both of the number lines. The horizontal number line we will call the x-axis. Okay? We generally just write x here, okay? This is the x-axis, the horizontal number line. The vertical number line we will call the y-axis. And generally we just write y there. Okay, these two number lines divide this plane. This is called the xy plane. You can think of the surface of the blackboard here as the xy plane. They divide the xy plane into 4 quadrants. Okay, starting in the upper right-hand corner, we call this quadrant 1, and we number counterclockwise. Quadrant 2, quadrant 3, quadrant 4. Okay. Now, how do we accomplish the link between ordered pairs of numbers, okay, and points in the xy plane? Okay, it's done in the following way. Remember, every solution here, every ordered pair of numbers had an x value and then a y value. X, comma, y. The x value is written first. Okay, you can think of there being, say, a man standing at the origin. Okay, and he gets a solution, okay, on a slip of paper. It looks like an address to him. And he gets something like this, x, comma, y. The first thing he does, he looks at the x value. If the x value is positive, remember he's standing at the origin. If the x value is positive, okay, he moves to the right. If the x value, on the other hand, is negative, he moves to the left. Of course, he moves a number of units designated by that x value. Then, after he's done this, in other words, either move to the right or the left, depending if x is positive or negative. By the way, if x is 0, he just stays where he is. He then looks at the y value. If y is positive, he moves up the amount of units designated by that number. And if y is negative, he moves down. All right? Let's look at some ordered pairs of numbers, and what we're going to do is try to put them onto the xy plane. Okay, since these ordered pair of numbers, when they come out on the picture, they're going to come out as little points. We say we are plotting the points. Okay, now let's get some. We'll come back to this equation a little bit later. Okay, let's look at the point 3, comma 5. We have an ordered pair of numbers, 3 comma 5. Okay, we want to know what point in the plane is represented by this ordered pair of numbers. Okay, the man is, remember, standing at the origin. He sees that x is equal to 3. That means from the origin, he moves to the right 3 units. 1, 2, 3. Okay, he's now over here. Then he sees that y is equal to 5. Okay, since y is positive, he moves up the 5 units. 1, 2, 3, 4, 5. Okay, this point represents the ordered pair of numbers, 3 comma 5. Let's take a look at that again. We have 3 comma 5. The man was standing here at the origin. The first thing he looks at is the x value here. By the way, the first number is called the x coordinate, the second one the y coordinate. Okay? He looks at the x coordinate, which is 3. Since x is positive, he will move to the right 3 units. 1, 2, 3. Then he looks at the y coordinate. Since y was positive, he moves up in the positive direction of the y-axis, up 1, 2, 3, 4, 5. Okay, and we put the point down there. We plot the point 3 comma 5. Okay, let's try another one. Let's say we want to plot the point minus 2 comma 1. Okay, now the man is back at the origin again. Okay, we see that the x value is minus 2. Therefore, he is going to move to the left. Okay, if x is negative, he moves to the left. He will move to the left 2 units. And then, since the y value is positive, he will move up 1 unit. This is the point minus 2 comma 1. X was negative, so he moved to the left 2. Y was positive, so he moved up 1 unit. Okay, now let's try another one. Let's say minus 1, minus 3. Okay, notice both x and y here are negative. The man is once again going to start at the origin. Since x is negative, he will move to the left. Because y is negative, he's going to move down. So this is going to be a move to the left and down. Okay, he starts off at the origin. He moves to the left 1 unit, because x was negative 1. Then he moves down 3 units, 1, 2, 3. And here we have the point minus 1 comma minus 3. To the left 1 and down 3. See, the x coordinate tells you how far you are from the y-axis to the left. In other words, if x is positive, you move to the right. If x is negative, you move to the left. The y coordinate tells you how far you are from the x-axis. In this case, we are down 3. Okay, let's try another example. 4 minus 2. X equals 4 and y equals minus 2. This is going to be a move to the right and down. X is positive, so we move to the right. Y is negative, so we move down. It's a move to the right 4, 1, 2, 3, 4, and down 2, 1, 2. And here we plot the point 4 minus 2. To the right 4 and down 2. Okay, in doing this, we see that the points in the first quadrant will have both of their coordinates positive. Their x value will be positive and their y value will be positive. Because how do you get into the first quadrant? You move to the right and up. Okay, in the second quadrant, the points will have a negative x value and a positive y value. A negative x coordinate and a positive y coordinate. Because to get into the second quadrant, okay, from the origin, we would move to the left and up. In the third quadrant, the points will have negative x coordinates and negative y coordinates, because starting at the origin, you move to the left and down. And finally, in the fourth quadrant, you will have a positive x coordinate and a negative y coordinate, because you move to the right and down from the origin to get into the fourth quadrant. Okay, that takes care of the quadrants. Now, what about points on the axes? Okay, A point on an axis is going to have either its x-coordinate or its y-coordinate equal to 0. Let's look at the point, say, 0, -3. The man gets these directions. He gets this point, 0, -3, is at the origin. X is not positive, so it doesn't move to the right. It's not negative, so it doesn't move to the left. He just stays where he is. In other words, X is 0 means he does not make a move to the left or to the right. Y is -3, so he then moves down 3. And here we have the point 0, -3. In other words, points on the y-axis will always have their x-coordinate equal to 0. Okay, the man is not going to move to the left. He is not going to move to the right. X has to be 0. He's either going to move up or move down. That's the only way he can wind up on the y-axis. Okay, in a similar fashion, points on the x-axis have their y-coordinates equal to 0. For example, let's look at the point 3, 0. The x-coordinate is 3, so he moves to the right 3. The y-coordinate is 0, so he doesn't move up and he doesn't move down. Whereas if you have an x-coordinate that is not 0 and a y-coordinate that is 0, you will wind up on the x-axis. In other words, you will move either to the right or the left, but you won't move up or down. In other words, you will stay on the x-axis if y is equal to 0. And here we have the point 3, 0. I'd like to now go back to the original equation that we started the lesson with, 3x plus 4y equals 12. And I'm going to try to get a picture of this particular equation. 3x plus 4y equals 12. We have a whole bunch of solutions listed here. We have one that's not a solution, but we do have several solutions. What I'm going to do is to try to plot the points, okay, represented by these solutions. Okay, and in doing so, we will get a picture of this particular equation. Okay, we've already seen how to plot individual points. Okay, we were just doing that aimlessly before. Now we are going to plot points with a purpose, the purpose being to get a picture of this equation, or the graph of this equation. Okay, the points that we'll plot, every point that we'll plot will be a solution to this equation. Okay. In order to do that, we will have to start with our coordinate system. We'll have our x-axis. Perpendicular to that, we will have our y-axis. Okay. This place where they intersect, of course, this point is called the origin. We will set off the units on the x and the y-axis. This is 1, 2, 3, 4, 5. Okay, -1, -2, -3, -5. And then +1, +2, 3, 4, 5, -1, -2, -3, -4. Okay. This is quadrant 1, 2, 3, and 4. Okay. Now let's see the points that we're going to plot. Well, I can cross this one. Well, this first one, x equals 4, y equals 0, is the point 4, 0. We want to plot that one. 0, 3. 1, 9/4. -4, 6. Okay. Let's see what we have. 4, 0. The first point we're going to worry about. x equals 4, y equals 0. The man is standing at the origin. He moves to the right 4. And then since y equals 0, he doesn't move up, he doesn't move down. He stays right on the x-axis. There we have the point 4, 0. Okay. And here we have 0, 3. X is 0, so he doesn't move to the left, he doesn't move to the right. Y equals 3, so he moves up 3 units. Okay, 0, 1, 2, 3. We have this point. Now the point 1, 9 quarters. 9 quarters, of course, is 2 1/4. So we will move to the right 1 and up 2 1/4. Okay, 9 quarters, this is also 2 1/4. 1 to the right, 2 1/4 up. 1 to the right, 2 1/4 up. Okay, in doing this, you begin to see one of the drawbacks, okay, of this technique, and that is it's hard to get points very accurate on the graph. Okay, if they're whole numbers, that's fine, but 2 1/4, you sort of have to approximate. Minus 4, 6, to the left 4, and then up 6. To the left 4, 1, 2, 3, 4, and up 6. Okay, now if we look at the points that I have down here, you will notice that they appear to fall along a line. This one is a little off. Let me just Here was the minus 4, 6, 0, 3, 1, 2 1/4, 4, 0. Okay, now this is not a coincidence. When you are trying to graph an equation of this form, by this form I mean something like this, ax plus by equals c. A, b, and c represent constants. A and b are not both 0. A and B are not both 0. If A and B were both 0, you can see what would happen here. You wouldn't have a line. You wouldn't have anything here. You'd have 0 equals some constant, which, unless that constant was 0, wouldn't even be true. Okay, so we're assuming that A and B are not both 0. A, B, and C are all numbers. Ax plus by equals c. We have an equation of this form. Turns out that the graph of an equation of this form, that is, the picture of all the solutions of an equation of this form, is always a straight line. Okay, the graph of an equation of that form is always a straight line. For this reason, such an equation is often called a linear equation. Okay, you can see why, because it has the word line in it. Graph of an equation of this form, the picture of all the solutions of an equation of this form, is a straight line. Such an equation, a first-degree equation in 2 variables, say x and y here, is called a linear equation. You've all heard the expression 2 points determine a straight line, and that's true. If you'll notice, if I just have 2 of these points, okay, I would have, of course, drawn the exact same straight line through them. Okay, so theoretically, 2 are enough. Okay, if you were sure you had 2 correct points, 2 correct solutions for this equation, you'd put them down. The line you would draw through them would be the graph of the equation. Okay, but we all make mistakes, so it's usually a good idea to say, try at least to get 3 points. Okay, this way, if there is an error, you will have some, if the 3 points don't fall in the same straight line, you'll know you've made a mistake. Doesn't mean that the 3rd point that you've drawn is the one that's wrong. Okay, maybe one of the earlier points is incorrect. But if you've done at least 3 points, you'll feel more comfortable, okay, more confident about your graph. Okay, let's try some more examples. Oh, by the way here, you can see why it's very important not to make a mistake and rearrange the coordinates. Okay, the first value has to be the x value, the second one has to be the y value. If you made a mistake and tried to plot this one, 0, 4, okay, you can see that would throw off your line because 0, 4 is up here. You don't move to the left, you don't move to the right, you just move up 4 units. It's very important that you be very careful and don't make mistakes and confuse 4, 0 with 0, 4. These are ordered pairs of numbers. The order is crucial. The first value is the x value. The second value is the y value. Okay, let's try to graph some more equations. Okay, the next one we're going to try is 5x minus 2y equals 10. By the way, if you look at the one we just finished over here, you will notice that included, okay, among the points we plotted was the place where the line crossed the x-axis and the place where the line crossed the y-axis. The place where a line crosses, say, the x-axis is called the X Intercept. And the place where a line crosses the y-axis is called the Y-intercept. Okay, these are very useful points to have. Okay, if you're going to try to make an accurate picture, it's very nice to know exactly where the line should cross the x and the y-axes. Also, these are very easy points to get. Okay, I admit in the first problem I sort of just gave you the points. In the next one we're going to actually work them out. We're going to make an effort to try to get the points, okay, where the line crosses the x-axis and the y-axis. You will notice that when the line crosses the x-axis, the point that we're looking for, of course, is on the x-axis. The place where the line crosses the x-axis is naturally on the x-axis. As such, its y-coordinate must be 0. We went through that before. The only way you can get a point onto the x-axis is if its y-coordinate is 0. You don't move up, you don't move down. Okay, similarly, if the line is going to cross the y-axis, the x-coordinate is going to be 0 because you're not going to move to the left, you're not going to move to the right, you're going to stay on the y-axis. Okay, using this idea, in order to get the x-intercepts and y-intercepts, we are going to let x equal 0 and y equals 0 in the original equation, solve for the corresponding value of x or y that goes with it, and make sure we plot those points, okay, while we're plotting the points for the solutions here. Now, you can make yourself a little table of values, and we're going to look for solutions for this equation. We want to make sure that we get the x and the y-intercepts, so we're going to make sure that we fill in the y value that goes with x equals 0 and also the x value that goes with y equals 0. Okay, now, don't feel you have to do this work in your head. You can go over to the side here and actually work it out. We would like to know what goes here when x is equal to 0. In other words, find the y value so that x equals 0 and y equals that number, make this a true statement. And the way to do it is to substitute into the equation x equals 0, so you get 5 times 0 minus 2 times y equals 10. X equals 0, and we want to solve for y. So we actually let equal 0, and we solve